what is mean by equilibrium of body? Like if body is said to be equilibrium, or if state is rest or in motion in state line, it's not altered. That means whatever forces acting on the body, if we find out a resultant, and if that resultant is zero, then we can say that this body is in equilibrium. What means resultant is resultant or number of forces acting on, like one body is there. Okay, one box is there. Two person pushing it from both sides. Okay, and both are applying same force F. So automatically this body is not moving. So we can say it as two forces are acting on that body, but body is in equilibrium. Why it is equilibrium? F in this direction, F in this direction. So if we take summation of forces, then what will happen? In x direction it will become 0, right? So in such condition, we can say that body is in equilibrium. Like another example with number of problem we solve, like this one example I have given. Okay. And number of forces F1, F2, F3, O, F. Okay. Now, when you start solving a problem to find out a result, and you got that what you converted that all forces into two force system, that is summation Fx and summation Fy. Okay, then you calculated resultant. Now, if this resultant is equal to 0, then automatically, if we say resultant is 0, then automatically summation f of x is 0 and summation f of y is equal to 0. Automatically, it will be 0, right? Then we know that when we say body in equilibrium, when resultant is equal to when resultant is equal to 0, and we know that resultant is equal to square root of summation of fx square plus summation of fy square. If this need to be 0, this need to be 0, both should be 0. Okay, that's why negative sign also will not affect because it is a square. So only chance of getting r is equal to 0 is that both should be 0. Okay, and from here what we understand that when body is in equilibrium, we need to have this condition. The summation of forces in x direction is equal to 0 and summation of forces in y direction is equal to 0. And these two conditions are called as a equation of equilibrium. Equation of equilibrium. And these two equations can be used to solve how many number of unknowns? Two equation means two unknown. I'll tell you how to get that two unknowns and all those things. Okay, but first you need to understand what is mean by equilibrium condition. Equilibrium condition means what? Body is in equilibrium. When we can say body is in equilibrium? If body is in motion, still the resultant force acting on the body is 0, or body is at a rest and still the resultant forces acting on it is 0, then we can say body is in equilibrium. When body is in equilibrium, as the resultant is 0, automatically summation fx and summation fy equal to 0. Okay, so this is called as a equation of equilibrium, and we are going to use this equation every time in our what you can say engineering mechanics whole class. So let's solve a simple problem. I need answer from you also. So two ropes are tied together at C. Okay. If the maximum permissible tension in each rope is 3.5 kilonewton, what is the maximum force P that can be applied and in what direction? Okay, I will write that problem for you. Two ropes are tied together at C. If the maximum permissible tension in the rope is 3.5 kilonewton, what is the maximum force P? Everyone please note down this statement, force P that can be applied and in what direction? In what direction? Please note down this. Okay, so what is the problem? There are two ropes. So by maroon color, I have shown those ropes tied at point C. Okay. If the maximum permissible tension in the rope is 3.5 kilonewton, what is the maximum force P that can be applied and in which direction? Now see, I'll give a simple example. Okay. Now tell me which type of force this rope can apply on this box. You know there are two type of forces. One is a tensile force, another one is a compressive force. Or forget about tensile and compressive. Just tell me it will be push or pull. Everyone, I need this. Can this rope push this box?
Pull.
No, no, never. It is not possible. Yes, pull only. So it is not possible to get push effect by a rope. Always remember. So whenever you draw a rope or remove support of the rope, always remember rope will always apply a tensile. Now in our case, now what we have to do is we have to draw this diagram without removing this or with removing. So these two ropes I have cut here. Okay. So once we cut, we got like this diagram where we know that I'll consider TA tension in A, TP. So TA, TB and force P. Okay. Now we are drawing a diagram. This is simple force or line diagram, right? And from here, what we understand, problem it is given maximum permissible tension. That means above which this rope will break. How much maximum force that rope can take permissible? That is 3.5 kilonewton. So we can write TA is equal to TB is equal to 3.5 kilonewton. Okay, TA is equal to TB is equal to 3.5 kilonewton. That is given. How we got? That is, first of all, how we cut this rope? We need a free body diagram, or we need this rope without any support. Okay. So what this rope can do? Rope can only pull. So this rope can pull in this direction, and this rope can pull in this direction. So we draw on the line diagram. Now we got all forces. This angle is 20 degree, and this angle is 50 degree. Okay. 50 degree and 20 degree. How? Because of Z, similar angle. Okay. Now they are saying to find out force P and angle of force P. We don't know angle. So what we can do, we can use our, let's consider when we cut this rope, we consider this whole body is in equilibrium. Once body is in equilibrium, we can use our equation of equilibrium, that is summation of Fx is equal to 0. That is forces in x direction is equal to 0. Now let's first get the forces in x direction. So P, I will consider this as theta. So P cos theta and P sin theta. TA, that is 3.5. This is so cos 50 3.5 sin 50. EB also is equal to 3.5. So we can write 3.5 cos 20 and 3.5 sin 20. So we have resolved our problem forces. Now we can use summation fx and summation fy. Okay, so what is summation fx? First, p cos theta plus 3.5 cos 50 minus 3.5 cos 20. Right now, 3.5 cos 50 minus the direction. See the direction. Let's write summation fx. That is equal to p cos theta plus 3.5 cos 50 minus 3.5 cos 20 is equal to 0. This is first equation. Second equation, summation of forces in y direction. Why we can use this equation? Because body is in equilibrium. So it is p sin theta minus 3.5 sin 50 minus 3.5 sin 20 is equal to 0. Just remember, go all okay. P sin theta is only positive, others are negative, is equal to 0. So we got equation number 2. Now use your calculator to solve this simultaneous equation. Okay, and get value of P and theta. Please solve this. Yes, wait fast. The answer. You can find out that answer afterwards. You can tell me. We'll go to the next topic. Now, just now we saw like three forces, three force system is there. Then we have one theorem that is called as the Lami's theorem. Okay, so let's study what is mean by Lami's theorem. Okay, so what is its state? Its state as if body is in equilibrium, it may be analyzed if body is in equilibrium, it may be analyzed using Lami's theorem under condition of three force. So mandatory condition is what? If you want to use the Lami's theorem, you must have three forces. What it states now is statement I will write. That is a general statement. I will write now actual statement. If body is in equilibrium under action of only three forces, if body is in equilibrium under action of three forces, then each force is proportional to sine of angle between the other two forces. The body is in equilibrium under action of three forces, then each force is proportional to sine of angle between the other two forces. So how to get it? We can use a sine law. Like I will show you how we can use sine law to derive this. Okay, just consider three forces in any direction F1, okay, alpha, beta, gamma. Now let's draw this force and in such a way that they can make a triangle. As we know, if we draw this F1 can be drawn here also, as it is parallel to the force and magnitude is the same. Direction and magnitude is the same. So this is F1. Then another force is, I'll use this as F3, and vertical downward force as F2. Now this becomes a triangle. Okay. Now just see here what I am doing. Along the line, angle is 180 degree, right? Along the line, angle is 180 degree. So if you see this angle alpha, this angle alpha, it is made by force F3 with respect to force F2. This is the force F3 and this is force F2. So we can write this as alpha. Similarly, we can write this angle as beta and this angle as gamma. How gamma? See, angle made by F1 and F2. How much it is? Gamma. Okay, so we have proved this. Now we'll write forces. So this vertical downward is F2 with at angle F3 and sorry, this is vertical downward F2 and this is F3. Okay, so F1, F2 and F3. Now triangle is done. Now what is science law says? Sine law says it is already done for mathematics. This ratio of what? Side of a triangle to the angle in front of that side are equal. So this is 180 minus alpha. This is 180 minus gamma, and this is 180 minus beta. Okay. So what it says? Side divided by sine of angle are in same ratio or constant. So we can write side. What is side? Let's write one by one. So F1 divided by sine of 180 minus alpha is equal to F2 divided by sine of 180 minus beta, or we can write F3 divided by sine of 180 minus gamma. Okay. So from here what we can do, we know that sine A minus B. So sine A cos B plus cos A sine B. So if you solve this, you will get f1 divided by sine alpha is equal to f2 divided by sine beta is equal to f3 divided by sine gamma. If you see this statement of Lamis theorem, you can see f1. Where is the f1? Here. Just look in this diagram. f1 divided by sine alpha. f1 divided by sine alpha is equal to f2 divided by sine beta is equal to f3 divided by sine gamma. So from here what we understand is Lamis theorem we can use when three forces are there, and this is like a shortcut. Only and only when you can use, mandatory condition is there should be three concurrent forces, not parallel or something. There should be three concurrent forces. Now we have another note. Always everyone we have to remember in life as an engineer. When we study this Lamis, there is one short note that when body is in equilibrium, when body is in equilibrium and subjected to three non-parallel coplanar forces, then it must be concurrent, means pass through the same point. Now how we can prove this? Let's see. First of all, read this. When a body is in equilibrium and subjected to non-parallel coplanar forces, then it must be concurrent. Let's draw arbitrary body. Let's consider three forces. Okay, one is okay. This body is in equilibrium. Okay, so this is diagram given. Three arbitrary forces are acting on the body. Let me say this is F3, F1, and F2. Let's use parallelogram theorem. Okay, then we'll get result of which forces F1 and F2. Okay, now just imagine you have one stone with a weight of W. Okay, and you attach one string that is in your hand. Okay, now you tell me how much force or tension will be in that string if body is in equilibrium. If body is in equilibrium, your first condition is what? Resultant should be 0. Okay, they are along the same line, so automatically the tension in the that string will be W. Okay, now what we will do, instead of this 3-pole system, I'll draw new diagram, same body. This is F3, and instead of F1 and F2, I will write resultant. Okay. Now, if body is in equilibrium, that means this force should pass through one point, right? And when if these two forces passing through same line only, then and only then we can say that body is in equilibrium, right? So automatically, what we are going to tell you that if this is R passing through this is F1, this is F2. So all three forces, if you join, then they should pass through one point. Okay, and that is a theorem that says if three forces acting on a body in equilibrium, then these three forces must be concurrent, that is passing through one point. Now next point we'll go to the is called as a free body diagram, that is called as a FBD. What we are going to study is free body diagram or FBD. What is this FBD? This let's consider and block is there which is resting on a table. Okay. Now we know that if we remove this table, then what will happen? If you remove this table, what will happen? The block will fall, right? So that block should not fall. That's why this table is applying a force in which direction, upward or downward? Tell me. Applying force in upward direction. Okay. So this force, this load, whatever applied by this, what you can say, table, we have shown by one force only or one arrow only at a point, and this is called as a free body diagram, that is free from support. Okay, let's draw another diagram. This sphere is kept in a trough. Okay, and it is in equilibrium. Uh, it is equilibrium. Okay, when body is in equilibrium, what we can do is we can remove all support, and instead of that support we can show those support by using the forces. So let's do one by one. First draw the sphere. Let's keep body as it is. Forces are acting on body, so let's remove the one by one support. So, and one rule you need to remember, when you remove a support, the force acting on that body will be perpendicular to the surface. That means table like this, so perpendicular to the table. Like that, here also it will be like this, and like this. So we can draw this here also. Yes. Okay. So this diagram is called as a free body diagram, that is free from all support. You understood this? How to draw a free body diagram? Yes, everyone, this is important. Now your question will be, sir, this table is applying load for this much length or area. So how you can show the point load? So for engineering mechanics, we converted that entire load which is acting on the desk or bench or table to a point load. Okay, so every time we are going to consider it as a point load only. So now I will give you some problem. You have to draw a free body diagram. If you can draw free body diagram, then you can solve any problem in engineering mechanics. First, and when we hatch any support, now that is fixed support. Remember, okay, if it is not shown, then it is a moving support. These are the fixed support. Please draw this free body diagram. You can name it anyway. Everyone, please draw free body diagram. These two problems. Simple. It is like 10-second work. Simple. It is first body is here, and one force is here perpendicular to this surface. If we remove this and one in this direction. Now for this block, three forces or three support are given. All are 90 degrees. Remember. Okay. So this is how we draw free body diagram. First, you got a free body diagram. You can solve any problem. It's we lost connection. But we have continuous two lectures and it will run for both of us. What we can do? Just take a 10-minute break and you can join again at 10:05. Okay? 9:55 to 10:05 you can have a break, small break, and at 10:05 again we will continue to next. You can draw free body diagram of bond. Okay, so you can draw this free body diagram during that time. You can have a 10-minute break. I will be online only. You can leave the class and come at 10:05, or you can be here or be connected and you can So start again. What, what I decided here today that we will not solve numericals based on this free body diagram or force system. What we will do, we'll jump to the next moment part, and during lecture we'll solve numerical, because I feel like when we solve numerical here, many couldn't get it, right? So we go to the next topic. Now in chapter 3, first is a basic concept, second is a full system, third is a resultant and equilibrium of system, coplanar, non-concurrent forces. Means in one plane, but they are not concurrent. Okay. So in this third chapter, first we have to learn new concept that is called as the moment of force. Okay, just see, it is not a movement, it is a moment. Okay, what is moment of force? I'll tell you. Now, do you remember I have given one example of box that you need to move from left to right, you apply force here. Okay, that's why it moves in this direction. Now, by mistake, what you did is you apply the force at one of the corner or near to the corner. Now what will happen? Does this body will move in this direction, or does this body will start rotating? What do you think? Tell me. Option number 1, option number 2. So you can speak. Unmute yourself and speak. Yeah, Nathan is saying yes. Second. So yes, body will start rotating, right? And this rotation caused by a force is we can call as a moment about an axis. Okay, so let's define what is moment of force. The moment of force about point moment of force about point is equal to is equal to product of the force and perpendicular, this is a perpendicular sign, perpendicular distance of the point from the line of action of force, from the line of action of so what is the moment of a force about point, okay, like this force I want to know about point O, okay, this point O to this force is having distance of x, or I will say instead of x I will say d, okay, distance is d, that this force is f. We can draw a simple diagram like this is the force and this is point O and distance between them is d. Then according to definition, what definition says? The moment of force about point is equal to product of a force and a perpendicular distance of the point from the line of action of the force. That means moment. What is moment? Moment is a force which create a rotation effect. Okay. So it is denoted by capital letter M and it is formula is F into D. Okay. So capital M is equal to F into D. So what point O call? Point O is called as a moment center, called as and this distance D is called as arm of the force. Arm of the force. Okay. So what is moment? Moment is a force which is acting eccentrically, which create a rotation effect of a body. Okay. And it is denoted by capital letter M and it's given where product of magnitude of force and the perpendicular distance of force and about which point it is moving. So which point you want? You want about point O. That's why if you want about another point like point Z, then it will be like force F. This is point Z. What is the distance between Z and let's consider X. The distance is X. So M is equal to M about Z and M about O is equal to F into X or XF. Okay. So this is called as a moment. Now let's go to the next theorem. Don't worry, I will when we solve a problem, you will understand this concept very easily. I'll say. Next is we have one theorem, big theorem. Only one theorem there in two modules. That is Varignon theorem. Now let's consider two forces F1 and F2. Okay. Let their resultant we calculated and we got it as F. Let's consider two axes, X and Y. The point where all forces are concurrent is E. Let force F make angle of theta, F2 as theta 2, and F1 as theta 1. Okay. What we are doing, we consider two forces F1 and F1, F2 at a point A, acting at a point A. Let we calculated F, that is a resultant of two forces. So we got this diagram. Now what we are going to do is we will consider one point O on y-axis. And what we are going to do is we are going to plot perpendicular from point O. Okay. So we have plotted the perpendicular, namely D1, D2, and this center one is D. So what is the procedure? We consider a point A on which two forces are acting, F1 and F2, making an angle theta 1 and theta 2 with respect to x-axis. Let F be the resultant of these two forces, making an angle theta with respect to x. Then we consider a point O y-axis along the y-axis and plotted project perpendicular on from point O. Okay. Let D1, D and D2 are the perpendicular distance from point O to F. Okay. Now let's do simple mathematics. Moment of force, moment of what it is about point O. So M, moment of force F about O, that is equal to force into perpendicular distance of point O to F, that is D. Okay, let's draw this simple thing like a triangle. This is D, this is force F, Okay, and this angle is theta. So automatically this angle will be 90 minus theta. Or earlier, like earlier I given one trick. Do you remember? Angle between these two lines is theta. Okay. Okay, angle between these two lines. What I will do later, will draw with other color. Angle between this force F and this line is theta that we already mentioned. Now these two lines are perpendicular to other two lines, so automatically this angle will be also theta. Okay, let's consider triangle OAB. Okay, triangle OAB. So we can write cos theta as, let's take cos theta. Cos theta is front side divided by hypotenuse. That is front side is, sorry, adjacent side divided by hypotenuse. So OA divided by, what is hypotenuse? Sorry, I am confusing you all. Sorry. OB divided by OA, or we can write OB is D divided by OA, or we can write D is equal to O into A cos theta. So let's write that. Why I am doing all those things you will understand when we'll reach to the final equation. OA cos theta. Okay, what we have done? We have taken a moment of force F about point O. What is the formula? Force into perpendicular distance between these two. Okay. Similarly, for F1, M of O for F1 is F1 into T1, or we can write F1 into OA cos theta 1. Okay. Similarly, F2 is for F2. For F2, it can be written as F2 into D2, or we can write F2 into OA cos theta 2. Okay. Now, what I will do, I'll keep OA common and I'll make this term as F1 cos theta 1. Just rearrangement. I'm not doing anything. OA into F2 cos theta 2. Let's go to the diagram. Okay. How was the diagram? This is your F2, right? Making angle theta 2. So what will be this x component and y component? Let's write. It will be F2 cos theta 2 and F2 sin theta 2. What from here, what we understand, we can write this as OA, and instead of F1 cos theta 1 or F2 cos theta 2, we can write force of x direction of 1, and we can write here OA force of in x direction of 2, a component of force in x direction of force 1 direction in force 2. Or similarly, here also we can write or we can write way f cos theta, similar like f1 cos theta, we can write force in x direction. Okay, let's give this equation number 1. So we'll write again here MOA is equal to OA fx for force F. For F1, moment of F1 about force is OA fx1. F2 is equal to moment OA fx2. Okay. Now let's give equation number 1, 2, 3. Okay. So let's add equation number 2 and 3. That is, what is MO? F1 D1 plus F2 D2 is equal to OA 1 into bracket fx1 plus fx2. Okay, what is F1 D1? It is a MO about of a force 1. Now, if you remember, when we solve any problem to find out a resultant like F1, F2, what we do? We find out their fx1, fx2, fy1, fy2, right? So then we get what we get? Two forces, summation of forces in x direction, summation of forces in y direction. These are the two components in x and y direction. From there we get a resultant. That means, what is summation fx? Summation fx we know is the addition of forces in x direction. That is fx1 plus fx2, right? So we can substitute that here is equal to OA into fx. I will write instead of summation fx. Okay. Here also write OA summation fx. Okay. Now according to Varignon's theorem. Varignon's theorem states that moment due to resultant is equal to moment due to its component. Okay, so we can equate this equation number 4 and equation number 1. What is that equation number 1? OA into Fx is equal to F1 D1 plus F2 D2, or is OA into Fx, we know that it is F into D. Similarly, for y direction we can prove. So what we prove here is F into D is equal to F1 into D1 plus F2 into D2. How we prove that? I'll tell you. See, F1 plus FD1 plus F2 plus D2 is equal to OA Fx. Okay, and if you go here also, what is MO? F into D. Okay, so F into D is equal to OA. I'll just give write properly. OA summation of Fx. So if you see both sides, OA summation Fx and OA summation Fx are same. So we can equate other side, that is F1 D1 plus F2 D2 is equal to F into D. So we got that equation, F into D is equal to F1 D1 plus F2 D2. And this equation says that this is a moment due to resultant is equal to summation of moment due to its component. That is called as a Varignon's theorem. Always remember this. Moment due to a resultant is equal to moment due to a force. Okay. Now this is more than enough for today. We'll meet again tomorrow because I need to solve some problems. Then only then I can jump on next topic. Okay. Today I'll share notes on okay, Teams. Okay, you will find notes of in Teams. So in section under notes, you can get it. So you have any doubt, you can ask me afterwards. Till that point, stay safe, take care.